Right, inverses. So there are two things about an inverse that you need to know. The first thing you need to know is that it undoes an operation. An inverse also reverses roles in an equation. There's only two roles in an equation: independent, dependent, input, output, x and y. So the x's are going to become the outputs, and the outputs are reversed into the inputs. So let me show you perfect examples. So on your first graph here, if you've sketched two coordinate grids, can you please, the best that you can, draw our little quadratic parent function the best you can. So we know it goes through the origin. And let's talk about these ordered pairs right here. These ordered pairs are going to be 2, 4, and negative 2, 4. So let's find the inverse. Remember the inverse, the x and the y's swap places. They literally just switch spaces. You don't change the sign. So for an inverse, oh, by the way, what's this ordered pair right here? Thank you. Let's switch all the ordered pairs and figure out what they're going to be. So negative 2, positive 4 is going to become positive 4, negative 2. So positive 4, negative 2, I'll say is right here. Positive 4, negative 2. I switched that one. Let me switch this one. So this is going to be 4, positive 2. Well, I'm just going to use my symmetry. 4, positive 2. And what about 0, 0? I mean, even if I try to switch that, it's still going to be the same dot. So here's the inverse. Right there. Now, is that a function? Would that pass the vertical line test? No. I knew it wasn't going to be a function because in my head, I used the horizontal line test for the original. So remember, your y values cannot repeat for the inverse to be a function. Let's talk about what will make a function. Let's go ahead and draw our buddy, the cubic function. So the cubic function, negative 1, 0, positive 1, positive 1. So this is y equals x to the third. You all know how this goes. It's kind of got a little bit of a swirl right there at the origin. Let's reverse these points. So remember, I have 1, 1, and I have negative 1, negative 1. So when I try to reverse these, what is going to happen? It would kind of draw the same graph, right? However, forgot to tell you something. Or did I forget? Actually, it's on purpose. So all inverses are reflected. but they're not reflected across the x-axis, and they're not reflected across the y-axis. They are reflected across this line that sometimes doesn't get as much attention as maybe it should. And that line right there is y equals x. All inverses are reflected across that line. Guys, the inverse has to exist for this. The inverse is going to be this, the cube root. So, if I have a line of reflection right here, which is y equals x, then guys, your cubic root is going to go through these points, but it's going to look like this. So that is your cube root function. Still goes through those points. The arrows are just going in the opposite directions. Not opposite, they're being reflected. So don't forget, all inverses, whether they're functions or not, are reflected across the linear parent function, y equals x. All right, that purpose, we're going to talk about that after we talk about our second part. So how do I tell if a graph is a function? It's reflected across the y-axis. The x and the y's are in switched spots. You keep the signs. All right, so now I'm going to give you a couple of equations, and you're going to determine if they're inverses without looking at a graph, without seeing if it's reflected or not. So let me give you some instructions on how to verify. So easy. How to verify, all you got to do is do compositions. So easy. All right. So I'm going to give you an example where it's not an inverse. Then we're going to do an example where it is an inverse. Then we're going to go back and fill out the purpose on that first page. So please write m of x. And m of x is going to equal 6 over x minus 4. And then we're going to have p of x. And p of x is going to equal 6 over x plus 5. And we're going to do a composite. So I'm going to put this into that, and I'm going to see what happens. So here we go. So the original was 6 divided by x minus 4. So wherever the x is, I draw a big giant open parentheses because that's going in there. All right, here we go. Oh, I don't even need those parentheses. So I can't do anything with that numerator, so I'm going to recopy it. I can't do too much down here either. All I can do is do 5 minus 4, which is plus 1. I mean, that's really all I can do with that. I'm stuck. I cannot clean this up any further. So we're not going to write anything yet. Let me give you a different example. Down here, leave some space. Like, don't write this right next to this because we're going to write something. Leave yourself some space right there. Let's look at another example. Let's say p of x was 6x plus 4. Okay, let me try again. I'm going to dump this into that And let me see what happens. Excuse me. So numerator, okay, and this is x minus 4. Let's put in the substitution. So this is going to be 6 over x plus 4. Oh, what's happening with those 4s? They do. Oh my goodness, we get to divide fractions. This is my favorite. Remember, when we divide fractions, we don't really divide. We keep, change, flip. Keep the top exactly how it is. Change the division problem into a multiplication problem. And you flip the fraction underneath upside down so it becomes this. What happens with those 6s? Yeah. Was that me? Or was that you? That was me. I'm sorry. They do cancel out. What are we left with? X. Oops. Y'all, that's what I'm looking for. But you have to do it twice. You have to do it twice. So I put that into that, and I got X. Awesome. Now I'm going to put this into that, and if everything wipes out except X, it's an inverse. But you got to do it twice. So here we go. Remember, this is 6x plus 4. All right, so let's put the other one in here. This is going to be 6 over x minus 4. Don't forget, this time that 4 was on the outside. So we get to divide the fractions first. Keep, change, flip. Keep, change, flip. Yeah, what happens with that? Tell me what to do. You got a couple options, actually. I could go ahead and distribute. Guys, y'all can break up those fractions. We do break up fractions and put them back together a lot. What happens here? What happens? What does that turn into right there? And what is 24 divided by 6? It's a negative 4. Good. All right, so back over here. That is going to turn into x minus 4. Now, don't forget you had that dangling plus 4. What are you left with? X. These are 100% inverses. These are 100% not inverses. Why? Did everything cancel out except here, except x? No. Did everything cancel out down here except x? Yes. What is x? Is it an input or an output? Is it independent or dependent? It's independent. If it's independent, can you change it? If the input was a 2, can you change the value of a 2? No. So, back to your purpose. Inverses, remember, it undoes an operation. It undid what we just had those functions for. The purpose of it is to get back to the input. Because it undoes an operation.